Hi everybody, and welcome to this video on exact values of trig, or we can call them special angles, or the trig values of these special angles. So before we get started, there's a few things that we need to know and remember. First, let's look at this triangle, this right angle triangle. Make sure you know which side is the hypotenuse, which side is the opposite, and which side is the adjacent. And then over here we have our SOHCAHTOA rules. We're going to be using these today. And finally, this Pythagoras theorem as well. We need to know this one. So if you're happy with all three of those, we can get started on our exact values. As always, if you have any questions about the things and the topics in this video, or you have questions about another topic, or you'd like me to cover another topic in a video, please comment down below, and remember to like and subscribe this video as well. So one of the ways we can work out exact values for certain special angles is by using our trig graphs. So for this graph of y equals sine x, where let's take an x value, so x is 0 at this point here, the y value that we get out is also equal to 0. If we move on to 90 degrees, sine of 90 degrees we can see is 1. So this is a good way to remember sort of 0, 90, 180. And you can see sort of the inverse is true for the cos graph. In fact, our cos graph and our sine graph are the exact same graph, except they're shifted slightly to the side. So, for example, if we moved our cos graph 90 degrees to the right, it would be the same as our sine graph. So if we put x as 0 into our cos graph, we can see that instead of getting 0 as we did up there, we now get 1. And if we put 90 degrees into our cos function, the value we get out is 0. So this is an easy way to remember some of the exact numbers for certain angles. And once I show you some of the other exact values for 45 degrees, 60 degrees, and 30 degrees, it becomes very easy to use these graphs to remember all of those values. So as long as you remember that the sine graph begins at 0, 0, and the cos graph begins at 0, 1, you can use these graphs, and you should be able to remember these graphs. If you remember that the sine graph starts there and the cos graph starts there, then you can draw out the rest of the graph and make sure that they cross the axes in the correct place and they're equal to 1, equal to -1 in the correct positions as well. So we can see that our tan graph is slightly different to the sine and the cos graphs. The tan graph also passes through the point 0, 0, but at 90 degrees it reaches what we call an asymptote. So the tan graph is never actually going to touch this x equals 90 degrees here. It just goes up and up and up towards infinity, and down here it never touches 90 degrees either. It goes down to negative infinity. So plotting this graph is helpful because it reminds us that there is no value for tan 90 or tan 270, and we can see at 0 it's 0, at 180 it's 0 as well. So the tan graph is less useful to remembering exact values, but then again, tan is slightly easier to remember than sine and cos as well. So you can use this graph in exams. What I recommend is remembering all three of the graphs. So sine, cos, and tan, remember what they look like, and you can quickly sketch those out in an exam if you need to. So the most foolproof way, in my opinion, to remembering the exact values for certain angles is by using what we call the special triangles. Before we get started, let's look at which angles we need to know the exact values for. So those are 0 degrees, 45 degrees, and 90 degrees. That's what this triangle is going to give us. We also need to know 30 degrees and 60 degrees, but that is for a different triangle. So for now, let's have a look at this one. So before we get started, let's label our sides. I'm going to work with this angle here. So this means that my hypotenuse is here. Let me change color. My hypotenuse is here. My opposite side is here. And my adjacent side is here. So because this is a right angle triangle, I can use Pythagoras' rule to work out the length of my hypotenuse. So you write it out first, a squared plus b squared equals c squared, where c is the hypotenuse. So let me put in my numbers. That is 1 squared plus 1 squared equals c squared. So 1 squared is 1, so my left-hand side equals 2. And so c, if I square root both sides here, I get c is equal to root 2. Let me label that on the diagram. And now because I've got the sides, I can work out, and the angle, so I've got all three of my values, I can work out the exact value when I put 45 into sine, cos, and tan. So first of all, let's write out SOHCAHTOA. And then using those, let's use the first one, let's use sine. So sine of 45 degrees, that is going to be equal to my opposite, which is 1 centimeter, over my hypotenuse, which is root 2. And we can also simplify this by multiplying top and bottom by root 2. So that's rationalizing the denominator. Maybe you know how to do that. But if I do that, I get root 2 over 2. So these are the exact same value. If you don't know how to rationalize the denominator, I will have another video on how to do that. Then let's have a look at cos of 45. So my adjacent, again, is 1 centimeter, and my hypotenuse root 2. So that actually gives me the same value of root 2 over 2. This is an easy one to remember. Sine 45 and cos 45 are root 2 over 2. Now let's have a look at tan. So again, I'm dealing with this top angle. So my opposite over my adjacent is 1 over 1. And that, of course, equals 1. So tan 45 is an easy one to remember. That's 1. Cos 45, sine 45 give us the same value, root 2 over 2, or you can remember it as 1 over root 2. So moving on to our second special triangle, we are going to use this one to work out the exact values of 30 degrees and of 60 degrees. So I've taken this equilateral triangle, and then with side length of 2 centimeters, and we've split it in half down the middle. Because we've split it in half, that top angle is now 30 degrees, and we have 60 degrees down here. So using this, let's label our sides. Let's deal with 30 degrees first. This is our hypotenuse here. This is our opposite, and this side is our adjacent. So once again, we're missing the length of a side here. We're missing this adjacent side at the moment, but we can use Pythagoras again to work it out. So this time we have the hypotenuse, so that is our 2 squared there. We don't have our adjacent. We do have the opposite side, which is 1. So if we work that out, that is a squared equals 4 minus 1. So a is equal to the square root of 3. So let's label that there and get rid of this working out. Okay, so now we've got all three of our sides. Let's deal with this 30 degrees. Sine first, so sine of 30 equals our opposite, which is 1, over our hypotenuse, which is 2. That's nice and easy, that's just a half. Then let's look at cos of 30. So cos of 30 is our adjacent over the hypotenuse. And let's just leave it at that, root 3 over 2. Now let's have a look at tan. So tan is opposite, which is 1, over the adjacent, which is root 3. Okay, so we can also rationalize the denominator here, so that would be root 3 over 3. Those are our exact values for sine, cos, and tan of 30 degrees. So let me just change color, and we will deal with 60 degrees now. So this time, my adjacent is this side. My hypotenuse, of course, stays the same, but now my opposite is the side that is root 3 in length. So sine of 60 degrees is going to be my opposite, which is root 3, over my hypotenuse, which is still 2. Cos of 60 is going to be my adjacent, which is 1, over my hypotenuse, which is 2. And then tan of 60 degrees is going to be my opposite, which this time is root 3 in length, over my adjacent, which is 1. And that, of course, is equal to root 3. So you can see that we've kind of done a swap around between the values. Sine of 30 is a half, sine of 60 is root 3 over 2. And the opposite is true for the cos values. So cos of 60 is a half, and cos 30 is root 3 over 2. Now, if we go back to our graph, so we can see on the graphs here at 30 degrees that our sine graph passes through a half. And we can see that it's lower, even if you're just sketching it, it's going to be lower at 30 degrees than our cos value. So this is the way to use the graphs to remember our exact values. At 0, well, that's easy to remember. Sine is 0, cos is 1. As long as you've got that clear and you can sketch out the graphs, the rest falls into place. So here at 30 degrees, our cos is higher, so that is going to be root 3 over 2. And sine is lower, so that's going to be our half. If we move on to 60 degrees, we can see that cos falls lower than sine here. So our cos value is going to be a half, and our sine is root 3 over 2. And finally, here I have a table of all of those exact values that you will need to remember for the exam. Now, obviously it's going to be tricky to remember all of those, which is why I've shown you those special triangles. So in an exam, you can use those to work out the exact values if you forget any of these. Remember, you can also use the graphs to help remember all of these values.